Kia ora, Year 11. I'm going to start trying to do some videos on algebra to help you guys out. Now, I promise you these are not going to be the highest caliber videos in terms of technology. I didn't have a tablet that's particularly well set up for this. I'm using a work computer and a sketch pad that's attached onto a USB. So I'll do my best, but these videos will still provide the mathematical insight, so do make sure you're listening and then follow along with me as well. Okay, let's have a go. This is the one of the examples for factorising harder quadratics. I thought I'd start with this because we were just factorising quadratics last lesson. So the idea is that when you've got 3x squared here, you can't exactly just split this into an x, x plus something. That's our goal, to get down to two brackets here. We've got two factors, but we don't know what they're going to be. We could trial and error it. We could go through a whole bunch of examples where we go, hey, look, this could be 3x, this could be x, because 3x times x makes 3x squared, and the only way to times to make 2 would be plus 1 and 2. But the problem is you could also have had 3x plus 2, x plus 1, and both of these would times to give you the 3x squared term and the plus 2 term. It's really about making sure you get this plus 7 in the middle. Now here, if we just reversed our operations, the 3x times the x is 3x squared. 3x times 1 would be 3x. 2 times x is 2x. These two here, they've only added up to give me 5x. The one here, 3 times x gives you 6x, and 1 times x gives you x. These two, the x terms, add to make 7x. So that's what we're going for. However, I don't want to trial and error every single one, especially under exam pressure. So we're going to go for a system that works every single time. Now, I call it the AC method. A lot of people use different words, but I think of it A, C, and B. Now, remember, this quadratic here could be considered as ax squared plus bx plus c. So we're going to find two numbers that multiply to make AC and add to make B. So we need times to make whatever A times C is. So times to make 3 times 2. So two numbers that times to make 6 and add to make 7. So two numbers that times to make 6 and add to make 7. Things that times to make 6, 1 times 6, 2 times 3. 1 times 6 actually works. So we're going to write this ax squared plus bx plus c, this 3x squared. All right, 3x squared. Instead of writing 7x, we're going to split this into 6x and x. And then you've still got your plus 2. Okay. The idea is we split the 7x based off this here. You're looking for two numbers that times to make 6, add to make 7. Those are 6 and 1. So we've written this as 6x and 1x. Here, we're now going to factorize, we're just going to factorize this bit here, and then separately, we'll factorize this bit here. Okay. So the first one, I've got a common factor of 3x, and then we've got x plus 2 left over. Now the second one has no common factor, so we'll just say plus 1. So 1 bracket x plus 2. Now the reason I'm putting a 1 there is just to make it clear that we didn't factorize at all, but actually we could always take out the common factor of 1, because 1 times x gives you 1x, 1 times 2 gives you 2, so it would work. Now here we've got a common factor of 3, of x plus 2 and x plus 2. Just going back to a much more normal factorizing question, if you had this 3xy plus 1y, your common factor here would be y, right? So you take that out to the front and you'd say, look, I'm left with 3x plus 1. That's exactly what we're going to do here. We're going to say, hey, look, we've got a common factor of x plus 1. We're going to take it to the front, sorry, x plus 2. We're going to take it to the front, and we've been left with this 3x plus that 1. And that's it factorized. So we would have x plus 2, 3x plus 1. The most common place where people get a little bit confused is going, how did you get from that step, this step here, to here? How did you do that? Well, the explanation is we've got an x plus 2 here and an x plus 2 here. They are both multiplied by the things on the outside of the brackets. So therefore, they are a common factor. Just like here, this y is a common factor. The x plus 2's can go to the front. We're left with 3x times x plus 2. So therefore, the remaining thing is 3x. 1 times x plus 2, our remaining thing is 1. So if we'd expanded this, we would have gone x times 3x plus 1, 2 times 3x plus 1, and you would come out with 3x squared plus 7x plus 2.